What's up, everybody? Welcome back if you've been here before. If not, if it's your first time, please consider hitting that subscribe button. Today we're talking about perpendicular bisectors. Perpendicular bisectors. Yeah, no, I saw him. Yeah, he was definitely a perpendicular bisector. It's weird to say, which is why I don't even use that word at all throughout the video, but suffice it to say that if a radii meets the edge of the circle and then intersects a chord at a right angle, that it will effectively cut that chord in half on either side, and they are geometrically forced to be equal. You could also think of it as an axis of symmetry for the circle. If you cut a circle in half, each side is symmetric. Therefore, a connected point should be equidistant from the radii. That makes sense, right? Okay, so let's jump into the video. Number 8, we've got a circle with a chord here of 14. Specifically, what does this right angle here tell us about this chord and the two pieces that compose it?
I'm not sure. Does it mean that they're intersecting?
It means that they are equal, and they have to be.
Oh, okay.
Because we know that this goes through the middle of the circle, right?
Yeah.
I mean, there's lots of ways you could draw this and it not be a right angle, right? Like there's a good example there. So it doesn't have to be a right angle. So that's really important, that we have to be given that that's a right angle for this to apply. But given that that's a right angle, that means that these two pieces are indeed equal. So that comes into play whenever we're drawing up this right triangle that you were just talking about.
Okay.
And then the rest of this, what we're given, they tell us this is 18. So I'm going to assume that this 18 is a what of the circle?
Oh, the what it's equal to?
Starts with a D.
Derivative?
No, not derivative.
Diameter. Oh, okay.
A diameter of the circle, right? It's the biggest number that's on there. It's the only thing that really makes sense, right? And this kind of comes back to, we've dealt with like poorly labeled things before, but if you think about it, this one makes sense and it can't really be any other way. Like, for example, 18 can't possibly be referring to half of this, i.e. the radius. All right, so now we know that that's 18. What does that mean about the radius of the circle? If that's the diameter, what's the radius?
9.
9, right? So I'm going to write in red. So now that we know that that's 9, do we know what this piece is here?
Oh, 7 and 7.
It'd have to be 7, right? So that's 7. Then we're just left with our x here. So how do we solve?
Pythagorean theorem.
And how do we tee it up? I'm not going to make us go all the way through it, but how do we set it up?
It would be 7 squared plus 9 squared.
Ooh, not 9. What is it? What's the other?
Oh,
What
x
is it? What's the
squared
other?
equals 18 squared.
Not 18. It would be the hypotenuse of the right triangle that we just made, which is, here, I'll highlight it in pink.
Oh, 9 squared.
9 squared. Very good. We got time for one more?
Yeah, that's perfect.
So there we've got another circle, and 9 tells me that I've got a chord, and then I've got a center, and then this thing goes through at a right angle, which means what about these two pieces here?
That they're congruent.
They are congruent. Very good. And we're actually given some measurements here. That's 4.2, and this is 10. So, and that arrow on the diagram is very specifically pointing to kind of the middle area. I think this whole thing is 10 here. I think that's what they're telling us. Does that make sense?
Yeah.
So whole thing is 10, and then they asked me about the radius. That's our x. So how do we start to tee up a right triangle out of here?
At the middle point.
Okay, so start here.
Yeah.
Seems logical. Where do I go next?
Come down to the dash by the I don't really know how to explain it.
Are you saying to extend a radius here?
Yeah.
You are correct. Because we know that we're always going to be like, that has to also be equal to x, right? If it's just a radius.
Yeah.
Okay, and then now it's in a more useful place. Do we know this leg here?
5.
And we know that y?
Because it's half of 10 and it's the radius, or because they're congruent.
Because they're congruent because of this right angle right here, that radius hits it at a right angle, therefore cuts this chord in half. Yep. So then what next?
Oh yeah, then you do the Pythagorean theorem, right?
Yep. So what's our equation look like?
Oh, x squared plus 4.2 squared is equal to 5 squared, right?
This is close. Sorry. Close, but not quite. What's wrong with it? Where's our right angle? It's here.
Yeah.
And then the leg across from that is always the what?
Oh, okay. So switch the x squared and the 5 squared.
Yeah, that x is always going to be our hypotenuse there. So, yep, there we go. That's what we want. And then we'll solve through that. Again, I'm not going to make us go through it because we already have like the number answer, but that's kind of how we set that up. All right, guys, I hope you found this video informative. If you did, please hit that like button. It's going to help me grow the channel here and make more content just like this. If you're new, again, consider subscribing. And there's definitely a link below to book if you want to schedule with me, Greg Newberry, That Math Guy. Again, I'll see you guys in the next video.